Hello, distinct learners. You are most welcome. So, in this video, we are going to solve an examination questions. Okay, and speed time graph. Okay, so this question, it is very important, such that each one of you guys should be able to, to solve. You should be able to know how to solve this question. It normally comes in both GC, okay, as well as grade 12 under question 3 in mathematics paper 1. So if you get any paper, any examination question paper is from ECZ, specifically for the grade 12s as well as the GCs, mathematics paper 1, you should be able to find question 3. It should be under speed time graph. Okay, great. So let us solve the question. The question reads: the following diagram is a speed time graph of a particle moving in a straight line. The particle decelerates uniformly from a speed of 35 meters per second to 20 meters per second in 10 seconds. Okay, so basically what was happening is that the particle, okay, it was decelerating. Okay, so it had to decelerate from the speed of 35 meters per second to 20 meters per second in how many? In 10 seconds. It then moves at a constant speed. So this, it was moving at a what? A constant speed, okay, for 15 seconds, okay? So meaning from here up to there. When it was moving at a constant speed, it had to to move for another 15 seconds. That is basically 10 plus 15. That's why we had 25 there. Okay, before it decelerates uniformly to come to rest at 40th second. Okay, yes. So when it moved with a constant speed or velocity, okay, which was 20 meters per second, it had to decelerate uniformly for another 15 seconds, which is 25 plus 15, and it took 15 seconds to decelerate. Great. Now the question is saying calculate the retardation. When we say retardation, is the same as they are saying deceleration, or rather negative acceleration. So negative acceleration is what is referred to as deceleration, or rather retardation. Okay, so retardation of the particle in the first 10 seconds. Okay, great. Then speed of the particle when t was equal to 31st seconds. See average speed of the particle for the whole journey. So the first question, we want to find the retardation. Okay, so retardation, okay, is the same as the negative what? Acceleration. Therefore, we have to find the what? The acceleration. But the answer should be negative. To imply to say we are talking about the retardation. Therefore, we say acceleration, okay, is equal to final velocity minus initial velocity divided by what? T, which is the time taken. From Newton, from the three equations of motion, which is we have final velocity is equal to initial velocity plus acceleration multiplied by time taken. We have final velocity squared is equal to initial squared plus 2as. Okay. We also have this, yes, which is ut plus half dt squared, like that. Anyway, you learn about this in physics, but my interest is this one. Okay, good. So from this one, okay, from the three equations, I've picked this one, okay, and I've just simply made a the subject of the formula. That's why I have acceleration is equal to final velocity minus initial velocity divided by the time taken. Good. I can now do what? collect the data. So my data is, okay, acceleration, I don't know, okay? And once I find this answer to be negative, it implies I'm finding the what? The retardation. So acceleration, I do not know. Final, velocity, okay? So this one, from the question, it is saying the particle decelerates soon from a speed of what? 35 meters per second to what? 20 meters per second. So here, the 35, it was the initial, okay? What it started with. And from here, the final velocity, when it was decelerating, it was what? 20 meters per second. So this is 20 meters per second. Okay, it started with what? 35 meters per second, like that. Okay, what about the time? The time from the question, it is 10 seconds. From here, I should be able to, substitute. I can say acceleration is nothing but equal to v minus u divided by t. So my final there, I know to say it's what? 20 meters per second minus 35 meters per second. The time is 10, like that. Okay, this is nothing but equal to, so I'll say 20 minus 35. Okay, this is a 15. Okay, negative 15 meters per second divided by 10 seconds, like that. This can be reduced. I have 15, I have 10, 5 can go there, I'm getting negative 3, 5 can go there, I'm getting 2. So this is a negative what? 3 over 2 meters per second squared, like that. So this is the answer. If you want, you can, transform or rather change this, improper fraction into a decimal number, or even a mixed fraction. Yeah, or even if we were to end here, should be able to get a mark. But remember, this negative, it implies to say the car was decelerating. So since we are finding the retardation, therefore retardation is equal to 3 out of 2, okay, meters per second squared. Okay, note that this as a negative, this doesn't have retardation. It implies negative acceleration, like that. Acceleration is negative because it was decelerating. Hence, the final answer is what? 3 over 2 meters per second squared. Yes. Great. Let us look at the second question. Speed of the particle when t was equal to 31 seconds. Okay. Second question. Okay, so speed of the particle when the time was 31st. So where the time was 31st is between 25 and 40. I can say here the time was 31st, like that. Okay, now I want to find the speed where this is where I want to find my speed. I can name this point as what? X. So there are so many ways. Okay, one would solve the speed, okay, where t was 31 seconds. So for me, what I'll do is I'll get this, this, I would say a triangle. It's like this. Okay. Okay. So that's a triangle. Okay. So there, here, the speed was 20. So this is 20 meters per second. And basically I have 25. This is 40. This is 31st. So I don't know my speed there. So I can use the concept of similarities and congruence. I can basically separate these. I have a big triangle, this one, and a smaller triangle. So I can separate them. Okay. Okay. then separate them. I have this, and I have a smaller triangle. So this is 31st, this is 40, this is X, this part. Then this is 20, this is 25, this is 40, which is in this part. This is the big triangle, and this is a smaller triangle. So basically here, what I'm going to do, I'll use similarities and congruence. Okay? So I can say speed, okay, will be compared to what? Length. Okay? So my speed here is 20. So I'll say I'll use, okay, big, okay, speed over length. So I'll say my speed is 20 divided by the length for this one is what? So my length here is, I'll find the difference, which is 40 minus 25, and basically I should be able to get 15, like that, which is equal to. Similarly, I'll get my speed is X, and my length there is, okay, I would say 40 minus 31st, and I'm getting a 9, like that. I want to find my X, which is basically the speed I should be able to cross multiply. So I would say 20 times 9, since this is paper 1, you don't have to multiply. Okay? You say, you just write it the way it is. Okay, this is 15x is equal to 20 multiplied by 9. Remember, this is paper 1. We don't want to work with big numbers. Okay? So, leave it like that. Okay? That goes up x is equal to, this is 20 times 9. So basically I'll look for a number which can go into 20 and 15 without leaving a remainder. If there is no number, I can jump to the next one, which is 9 and 15. And basically there is a number. So I would say 5 there is 4, 5 there is 3, isn't it? 3 there is 1, 3 into 9 is what? 3. So I have 1 there. 4 times 3 is basically 12 divided by 1, which is just what? 12 meters per second, like that. Remember, units, they are very important. So here the answer is 12 meters per second. So the speed of the particle when t was 31 seconds, the answer is 12 meters per second. Okay? So I can also try to use another way or method. Okay, just to make sure if I'll get the same answer. Okay, so here look at this. Okay, I want to find the what? My final velocity. So the initial here, when this was decelerating, the initial, it started with what? 20, isn't it? Meters per second. And when this was decelerating here, there, that was the what? The final at x, where t was 31st. So I don't know my final. I can put a question mark like that. I'm collecting data now. Okay, my initial is 20 meters per second, isn't it? Great. What then? My final, I don't know. What about my, when it was decelerating here, okay, which is the negative acceleration, okay, it was found, which is it? Okay, no, it was not found. We can be able to find the acceleration, okay, yes, which is basically the negative acceleration, the deceleration in the last 15 seconds. Okay, so one thing which we're supposed to know is that end point, okay, here, okay, either at if you say suppose we're at 26, maybe 29, anything, it experiences the same deceleration. Hence what happens, I'm supposed to find the deceleration. So I'll say, okay, I'll use okay, 20 as my initial, and my final is what? There, when it came to rest, my final is 0. So I'll find the deceleration for in the last 15 seconds. Okay, and remember, any point or a number, it experiences the same deceleration. So even at when t was 31st, it was experiencing the same deceleration where here. Okay, so I will say acceleration is equal to final minus initial divided by time taken. Okay, then I'll say acceleration is equal to my final was 0 minus my initial was 20 divided by, okay, remember I want to find the deceleration in the last 15 seconds. The time there is 15. Why 15? 40 minus 25, I should be able to get 15. Therefore, this is negative 20 divided by 15, and I should be able to say 5 there, that is negative 4. 5 there, I should be able to get what? A 3 meters per second squared. So my deceleration was negative 4 over 3 meters per second squared. Okay, now we want to find the speed of the particle when t was in 31st seconds, isn't it? So where this t was 31st is here. So the elapsed time, okay, from 25 up to 31st, I'm supposed to find the difference. So I'll say t, elapsed time, which was 31st, minus 25, and basically this should be 6 seconds. Therefore, final is equal to initial plus, okay, acceleration multiplied by t. So v is equal to the initial was 20 plus, remember the acceleration should be negative. Why? Because it is deceleration. This is I would say okay, 4 over 3 multiplied by the time, which was what? 6, like that. Therefore, v is equal to 20. Okay, so look here, positive times negative is negative. 3 into 6, this should be 2. 4 times 2, this should be what? 8. Therefore, v is equal to 20 minus 8, which is 12 meters per second, like that. Okay, so note that we are getting the same answer. So basically, that's how we are supposed to solve. You can use this method or their first method. Great. Let us look at their last, okay, the last question, which is saying average speed of the particle for the whole journey. Average speed for the particle, of the particle for the whole journey. Great. Okay, so the average speed of the particle for the whole journey, we know to say speed, okay, is equal to the total distance traveled divided by the time taken. So we have to find the distance as well as the time. Okay, so in this case, when we are collecting data, okay, our distance here, it can be found, isn't it? Great. But what was the time taken for the whole journey? It was 40 seconds. Speed, that's what we are looking for. As for the distance, it can be found by looking at the what? The graph. So if you look at this graph, we want to find the distance. And distance, okay, covered, the distance is basically just the under, the area which is, under this graph. So if we look at this, okay, it is making the shape of a trapezium. Okay, it is making the shape of a trapezium. Okay, so it is making the shape of a trapezium, where a trapezium, the distance, okay, so this is a trapezium. Again, from here up to this, it is making the shape of a trapezium. So the whole of this, I can call it to be G1, and from here up to the last part, I can call it to be G2. Therefore, my distance will be G1 plus G2. But one thing which I'm supposed to take note of is that the G1 and the G2 both are trapeziums, and the formula is given by half, okay, A plus B multiplied by what? H. Okay, great. Where A and B, they are parallel to each other, but A is the shortest distance and B is the longest distance, and basically H is the height. So if you look at this graph very well, okay, this is the shape of a trapezium. This is the shape of a trapezium. This is 0, this is 10, this is 20, and this is 35. So how do we get A and B? So for A and B, it's very simple. Just look for two lines which are parallel to each other. So in this case, if you look at this line as well as the other line, these two lines are parallel to each other. If you look at this line and this line, they are not parallel. Else, how do we get our A? Our A is the shortest distance. So from here, okay, up to this point, this is where we will get our A. So basically, our A, if we are to check, we are moving from 0 up to 20 is 20. Then we come to B. B is basically the longest distance. We are moving from 0 up to 35, so our B is 35, like that. What about H? H is very simple. You get H from those two lines which are not parallel to each other. So this is where we get our H. So H is from 0 to 10. So H is what? 10. Therefore, D1 is equal to half. Our A is 20 plus our B is 35. Our height is 10. Therefore, D1 is equal to, okay? We'll say half, okay? These two can go into 10, we'll get 5. So this is 20, 20 plus 35. Then 2 into 10 is 5. Therefore, 20 plus 35 is 5. Multiply by 5. Okay. 5 times 5 is what? 25. We can write 5. Remainder 2. 5 times 5 is 25 plus 2. This is basically 27. So 27 meters. I can do the same thing. I want to find D2. I will use the same formula. A plus B multiplied by what? I. So D2 in this case is half. What is my A? I'll check. Look. So from here up to there, we look for two lines which are parallel to each other. So this line and that line are parallel. So we can get our A and B. So basically, okay. So basically, okay. We are looking at this. Trapezium. We have what? This is 20. This is 10. This is what? 25. And we have 40. Like that. So, where do we get our? This is A. From here up to this point. That's where we get our A. Okay? Good. And our A should be 25 minus 10, which is 15. Okay? Plus our B, we are moving from here up to the last point, which is what? So B is what? 40 minus this number, which is there. So what are we going to get? 30. So this is 30, like that. Okay? Our height, two lines which are not parallel to each other. So from there up to that point, okay? From here up to that point, our height is 20. Good. So now, look at this, okay? We are solving. So 2 there is 1, 2 there is 10, 15 plus 30 is basically 45, okay? Multiplied by 10, and we should be able to get what? 450 meters, like that. Great. Now, we found D1 and D2. So therefore, the total distance should be, okay, D1 plus D2. D is equal to, our D1 is 275 plus our D2 is 450, like that. And basically, okay, this is supposed to be, okay, 725 meters. Therefore, we found what? The distance, which is 725, like that. Okay? Remember, we are finding speeds now. We can substitute. Distance 725. Time is 4:14, like that. So this can be reduced. Remember, this is paper 1. Look for a number. In this case, we can try 5. Okay, 5 into 40 is 8. 5 into 7 is 1. Okay, remainder 2. 5 in there I can't, so we add a 2. And what are we going to get? This is 22. 5 into 22 is 4, so we have 1 and 4. Remainder what? 2. We can add 5 there. This becomes 25, because 5 can go into 2. So what happens? This becomes what? 5. So we have 145 divided by 8. Speed is equal to, okay? So we can say 8 into 14, okay? 8 into 14 is 1, okay? Is 1. Remainder 6. Yes, remainder 6. Okay, great. So 8 into 6, it can, so it can go, so we get 5. This becomes what? 65. So 8 into 65, which is basically 8. We know 8 times 8 is 64. Remainder 1. 8 in there, it can't. We point. We add a 0. 8 into 10 is 1. Remainder 2. 8 into 2. Okay, so we add a 0. Then it's 2. Remainder 4. 8 into 4, we add the 0. Can't. This becomes what? 8 into 40 bits becomes what? 5. Okay? Yes, so this is meters per second, and this should be your answer. Thank you for watching this video. Make sure you click on the subscribe button and be ready for our next video.